Good evening, everyone. Yes, I think we have a lot of students who are already onboarded on the platform. I think we have Anit, Lahari, Shehnaz, Venu, Sai, Preeti, Pooja. Uh, yes, quite a few students. Devisri and Akila, Jayapriya. A very warm good evening to all of you. I'm extremely sorry for the inconvenience caused in the last session in the statistics because there was a sudden power breakage from my side and there was some kind of internet. So I'll try to see that we are starting little fundamentals, whatever I've already completed, and just gist of what is that we have already discussed, and on top of it, I'm going to build on the frequency distribution. I'm sure if you remember or if you recollect, we are focused mostly in the statistics. There are three important things what we have discussed is mean, median and mode, and we've also looked at what are the applications of it, and then post that we have started focusing on the frequency distribution. Today I'm going to discuss on the frequency distribution, how do you calculate the mean, median and mode, and then we'll also look at quickly on the deviations, mean deviations, standard deviations and quartile deviations. And today I'll promise you, I'll see that we are completing the session little early because it's a carry forward session. So, but please see through that all of you are staying focused for next 1 hour, and we'll try to maximize as much as possible. Thank you all for joining. With that note, let me quickly take you through the take you through the rest of the concept. So let's look at quickly on the, if you recollect, all this has been discussed, so let's not spend any time. Let me directly get into the frequency distribution. So if you look at, so we are in the frequency distribution data, we are really interested in calculating, if you recollect, we are really interested in calculating mean, we are also interested in median, and we are also interested in calculating mode. But if you recall, mode is the number which is having the highest frequency. So if you look at, there are 40 students who got 3 marks. So obviously the mode in this case is going to be how much? 3. I don't need to really spend any energy for that, because mode is the one which is having the highest frequency in the given data. Yes, similarly, if you look at median, median is nothing but a middle value. If there are even number of observations, I'll have 2 middle values. If there are only odd number of observations, only 1 middle value. Now, how many values if you have? If you look at, yes, one of the ways of is calculating the values 10 plus 20, 30, 70, 90, 100. So what is the total number of observation? Normally it is represented with sigma f, because frequency is f, observation is nothing but x. So how many marks students are scoring? X. And how many students are scoring that particular mark? Frequency. So sigma f is going to be absolutely 100. So when I look at the middle values, 100 by 2, which is going to be 50. So 50th observation and 51st observations are going to be middle value. So I need to, because there are 2 middle values, I need to take the average of it. Now, rather, one of the easiest way, if you remember, I suggested look at the cumulative frequency. So when I say cumulative frequency, until 10 we have ones, 10 plus 20, how much it's going to be? 30. Until 30 we have twos, and 30 plus 40, 70, up to 70. Between 30 to 70 we have threes, and between 70 to 90 we have fours, and 90 and 10, 100, because this gives a very fair idea of where it's going to be, because up to 30s I only have twos, and up to 30 to 70 we have 3. So definitely 50th observation is going to be how much? 3. And 51st observation is also going to be 3. So definitely the average of it is also going to be 3. So as far as this distribution is concerned, we do know the fact this is the mode is 3 and median is also 3. This is what have been discussed as a part of last session. Unfortunately, no, there was, from there we have stopped because of the power breakage or power supply. Now let's focus how to calculate the mean. We already know the fact mean is nothing but sum of the observation divided by number of observation. But I have how many tens? I have 10 ones, and I also have 22s, I have 43s. So if I start adding individually 1, 1, 1, 1, 1, 10 times, it is obviously going to be 10. Rather, directly I can compute. For example, if I adding 1 10 times, 1 plus 1 plus 1 plus 1 10 times, rather I can say 10 into 1, which is also going to be absolutely 10. So this is popularly represented with fx. So 1 into 10, which is 10, 2 into 20, which is 40, 3 into 40, which is 120, and similarly 4 into 20, which is 80, 5 into 10, which is, you look at, this is represented with sigma fx. In fact, mean in the frequency distribution is represented with mu. It is nothing but sum of the observation divided by number of observation, or we can also say sigma fx by sigma f. So if you look at 10 plus 40, 50, 50 plus 120, 170 plus 180, 170 plus 80, 250 plus 50, which is going to be 300. 300 by number of observations are going to be 100, because we have already calculated as a cumulative frequency as 100 here also and here also, which is absolutely going to be mean. So if you look at as far as this distribution is concerned, all the mean, median and mode are absolutely equal. So in fact, it is a perfectly symmetric data which I have taken. And we've also learned the fact in a partially or symmetric data, what is the relation between mean, median and mode? If you recollect, mode is always equivalent to 3 median minus 2 mean. We have also learned the fact the relation between mean, median and mode is always going to be how much? 3 median minus 2 mean. Now, what are these values? Why is significance? Yes, we are going to look at little later. Let's stay focused first on understanding how to calculate little more in detail, and by taking as many couple of examples, so that you will appreciate little later what need to be done with these values. So let's look at a couple of questions. So now look at the question. I've already broadcasted here. Let me see how many of you can do it. Yes. Now floor is open to all of you. Please see through that you are yes, attempting without fail. I've already broadcasted the question. Yes, there is the following table represents the weight of 24 students. Find the mean weight of the students. I'm sure given time anybody can do it. How well you are able to solve it, for me more important. And in fact, we are going to look at multiple ways of approaching this question. I've already broadcasted this question, so you can actually see the question as part of ICQ. And we are going to look at what are the best ways of approaching the question, not just solving the question, because given time anybody can do it. But the only thing, the advantage you will be able to get it once you start looking at how to minimize the time. Is there any better way of approaching the question? I keep saying whenever you are reviewing any test, I will always focus on whatever the questions I've attempted rather than I've not attempted. For me, the value addition in the questions which I've already attempted is more important rather than the concepts which I'm not aware. In order to maximize in those areas, I definitely need to spend the time. Rather, I will always focus on the areas which I'm really good at, and I'll see that I'm reducing the time for it. Then I'll slowly see that I'm also working on my weaknesses to convert into strengths, which is very important. That is why I keep saying my students, please focus on the questions which are already attempted. See, is there any better way of approaching them, and try to adapt to the new method so that you will be able to maximize. Now let's get into the question. I'm sure given time anybody can do it, but let's look at the various ways of approaching the weight of the students. So observation has been given. Sorry. Yeah, so observation, let me weight of the student, which is, let me take it as x, which has been given as how much? 34, 36, 37, 39, 43 and 45, and I do have the frequency which is given as 2, 4, 5, 7, 3, 2, 1. Yes, now we are really interested in what do you call mean weight, so which is going to be, obviously we will be able to calculate f into x, so can we calculate this? Yes, I can do 34 into 2, 4, 144, 37 into 5, 530s, 150 plus 35, 185, so 39 into 7, 740s, 280, 280 minus 7, which is going to be 273. Yes, you need to be really comfortable with fundamentals. So 43 into 2, 86, and this is going to be obviously 45. Yes. Yeah, so if you look at sigma fx, I need to add 8 plus 4, 12, 17, 20, 26 plus 5, 31, 3. So if you look at 3 plus 6, 9, 23, 23 plus 18, 41, 41 plus 7, 48 plus 20, 68, 68 plus 12, 80, 88, 92, 921. I'm hoping that all of you are getting something similar. And what about sigma frequency, sigma f? So 6, 11, 18, 18 plus 3, 21, 23 plus 1, 20, yeah, 4. So if you look at I'm looking for a value which is going to be definitely 921 divided by 24. Hope all of you are getting the same. In case you have any different things, please see through that. All of you are, yeah. So if at all, if you are looking at, for example, can we say if it is 1000? Can we say if it's 1000? Approximately I can say it, or probably if it is 960, I can say definitely it is very close to 40. And I'm looking for 921, which means it has to be definitely less than 40. Unfortunately, I have quite a few values which are less than 40, and they are very close. So that is where your knowledge has to be stronger. So can I express as 960 minus 24 is going to be definitely how much? 938. 938. Yes, are we agreeing? Probably 948, 938. So if it is 938, I do know the fact it's going to be 39, but it is 929, which means it has to be slightly less than 39 and close to 39. The only option I can think of here is going to be option 2 without doing anything. Yes, I know I've been little fast for some of you, but please see through that. In case if you have any doubts, feel free to ask me. All I'm saying is it's the values is, the moment I look at the values, I should be able to get hold on the numbers. So that comes with a little practice. But having said that, if at all calculators are allowed, yes, you can make use of it, but not every exam is going to allowing the calculator. So that's the reason you need to really get comfort on the numbers. I'm going to this is one of the ways of solving if you're really good at numbers, but normally I'll also tend to solve in a different fashion. Look at, let's see how many of you can make it. Now the same question, if I were you, what is the middle number here? Let me take 39 as the middle value. Yes, so let me take, this is an assumed average. I'm not saying this is an average, I'm assuming that this is an assumed average. Now 34 is how far away from 39? Minus 4. 36 is how far away from 39? Minus 3. 39 is how far away from 32? 7? 2, minus 2. 39 and 39, 0. 39 and 14, 1. 43, of course, 39 and 43, there are 4 units away, and 6, 45, which is going to be 6 units away. Now, how many such observations? So 34 is 5 units away. How many such observations? 2 such observations. 2 into minus 5, 10. 4 into minus 3, minus 12. 5 into minus 2, minus 10. 7 into 0, 0. 3 into 1, 3. And 2 into 4, 8. 1 into 6, which is 6. Now, if you look at, this is how much? Positives are 17, 3 plus 8, 11, 11 plus 6, 17. Negatives, if you look at 32. So, which means I have more negatives. So, which means what is the net impact? Minus 15. Minus 15. Now, look at very carefully. My assumed average is 39. 39. And I need to see that I'm subtracting 15 from this, but this 15 has to be distributed over how many observations? 24 observations. So what is the net impact? Please see through that. The net impact is minus 15, which has to be distributed over how many observations? 24 observation. Or I can say this is absolutely going to be how much? 3 5s, 3 8s. So it is nothing but 5 by 8. What is the value of 5 by 8? 0.625. So what is the required value? 38.375. Yes, I'm going to get narrowed down to the absolute values. Now the beauty of this method, what I'm doing, I'm making use of the deviation. So I'm not really operating on the bigger numbers. I'm not operating on 39. In fact, I'm operating on how much it is deviating from the 39. The advantage is I'm not going to deal with the bigger numbers, rather I'm only operating on the smaller numbers, especially calculators are not given. I'm going to make use of this method, which is very which is going to save a lot of time in terms of, not only in terms of computation, in terms of approach towards the question. So this is how I'm going to calculate the mean, rather than trying to find out every value and multiplying. So yes, if there are any better methods, we need to see that we are adapting it. That's how we are going to calculate the mean. And similarly, let's look at a couple of more questions, how to practice from your end. Let me see how many of you are able to make use of it. Knowing is no use for me. How many of you are able to applying it for me makes a lot of difference. Yes, let's quickly move on to the next question. I've already broadcasted the next question. Please make sure that, let's see how many of you can do it. You have absolutely 1 minute. Yes, I've already given. Now this question, yes, even though I've asked the median, initially I request you to calculate the median, and I am also interested in calculating the mean as far as this question is concerned. Now open to all of you. Please see through that all of you are calculating the mean and median as well. In fact, median and mean as well. Now floor is open to you. Let's see how many of you can do it. Yes, feel free to ask me if somebody is not able to understand. And I think we have quite a few other people also joined. Welcome on board, all of you. But make sure that you are responding. Make sure that you are learning the things from sessions. Yes. Again, following table represents 40 students. The good thing is I already given there are 40 observations. Now that is where you need to be very eclectic in reading, and I've already given 40 students. Find the median. So when there are 40 students, who are going to be my middle observations? 20th and 21, because there are 2 even observations, so definitely there are 20. Now how do I calculate the median? So I've already told you observation height here, 124, 128, 130, 131, 135 and 138. Now what are the frequency we have? There are 4 students here, 5 students here, 13 students here, 10 students, 5 students, 3 students. Yes, good thing Monica says 130. Let's see. Yes, it should be valid. Good. If you have already done, excellent. Please see through that you are calculating the mean for the same. Yes, Vamsi and Monica, absolutely right. Please move on to the mean for the same question. So let's me look at cumulative frequency. If I were you, there are 4 plus 5 9, 9 plus 3 22. In fact, I don't need to really look at all of them. 32, 37, 40. So if you look at, definitely the observations no, 20 and 21 are following in this. So what is the value it's going to be? Definitely it's going to be how much? 20th observation is also 130, 21st observation is also going to be 130. So what is the median of it? Median of it is going to be no, average of it, so which is also going to be 120. Yes, all of you are absolutely right. So that's 130 is absolutely right. Why is 130? So now we are really interested in mean. So Sai says median being 130.625. Yes, so let's see what is going to be the mean. I already told you I don't want to waste my energies in multiplication. So if I were you, because I know the fact, the middle observation either can be 130 or 131. What is that I normally prefer? I prefer 130 because it's easier to compute rather than taking 130. So if I were you, what is that I do? I'll assume that the assumed mean as 130. So let me look at 124, 6 units away, 128 minus 2 units, this is 0. 131 1 unit away from 130, and 135 5 units away from here, and 138 8 units here. So if you multiply 6 into 4 minus 24, 2 into 5 minus 10, 0 into anything will be 0, 1 into 10 10, 5 into 5 25, 8 into 3 24. So if you look at the beauty is 24 24 get nullifies, 10 10 get nullifies. What is the net impact? 25, positive 25. So the good thing is the new mean is also going to be 130 plus 25 has to be distributed over 40 observation. Definitely it is going to be 5 by 8, which is absolutely going to be 130.625. Yes, Sai, you are absolutely right. The mean is going to be how much? 130.625. Now what about the 131 cannot be? Bhavani, please look at. Bhavana, look at. So similarly, what is going to the mode? So if you look at the maximum observations are happening for 130. So the mode is also going to be, in this case, the mode is going to be how much? 130. Mean is going to be 130.625, and median is also how much? 130. Yes, that's good. Now let's look at another question for practice, then we'll move on to the different concepts. Yes. Quickly look at and find the mode of this ages. It should not take really much of your time because I'm asking to just calculate the mode of it, because I've seen questions in which what is going to the mean or median or mode of it. It should not take a really hardly 30 seconds. I am really in. Let's see how many of you can do it. In fact, I want you to calculate both mode and median as well. I'm really interested in calculating the median and mode. People who has already done for mode, please see through that you are fighting for the median as well, because I'm really interested. So I see Lahari says 13. Okay, so age of the students 12, 12.25 and 12.75 years, 13 years, 13.25 and 13.5 and 14. Yes, you also have a frequency which is, if you look at 3, 5, 8, 9, 2, 2, 1. Yes, for mode you really should not take really so much of time. It's been very simple because the highest observation, because there are 9 students who got 13 years, so I can definitely say mode has to be how much? 13 years. But then I'm really interested in calculating the median as far as this question is concerned. Median and mode are going to be 13. Aziz, I want you to be a little more careful. Look at how many observations. So let's look at quickly median sigma f 3, 3 plus 5, 8, 8 plus 8, 16, I think you might be right. 16 plus 9, 25, 25 plus 2, 27, 29, 30. So how many observations are going to be? Yes, if you look at 30 by 2, which is absolutely going to be 15. So because this is even in number, both there are two middle observation, 15 and 16. Now if you look at 15 and 16 are definitely going to the part of 12.75 or part of 13. Part of 12.75 or 13, definitely there, because anything below between 8 to 16 are only 12.75. so in fact the observation of 12 is 15 is also 12.75, 16 is also 12.75. so definitely the median is going to be how much? 12.75. Yes, it can never be, the median cannot be 13. Now here let's say for various reasons this is 3 and this is 8 and this is 15, this is 25. Probably instead of 8 I've given 7 here, 7, then it will be how much? 7 and 10. 8 and 9 instead of I've changed it, so then it's going to be how much? In this case what will happen, then 15th observation is 12.75. Beyond 12 to 15, which is 16th observation, is going to be part of 13. Then I need to take the average of it. Fortunately, because both of them are absolutely as part of this group, as far as this question is concerned, still median is going to be 12.75. Yes, I'm hoping that all of you are able to make some sense of it. Yeah, feel free to ask me in case if you have any doubts, because as far as this question is concerned, because there are 30 observations, so which means the middle observations are going to be 15 and 16. Both of them are fortunately part of the 12.75, thereby I am saying median is also going to be 12.75. But some cases what will happen, the 15th observations will be the part of 12.75 and 16th observation will be part of 13. Then what you need to do, you need to see that you are taking the average of 12.75 and 13. Yes, we do have certain questions a little later. We will be looking at, yes, thank you. Let's move on to next question. Let's see. Sometimes they'll just change. This was the question which is given in TCS last year, and because in the last year onwards CTS, the emphasis on the elementary statistics is significantly high. Let me see how many of you can do it. Please, this is how they do give it, but let's try to understand this question. Unfortunately, TCS. Yes, Hanivas, I will explain as a part of another question. Still, if you are not able to make it, we will discuss. Let's know. Now, after frequency distribution, you also have a class interval. Now, below 10 here, sometimes it is impossible to measure. For example, sometimes if because there are only 5 marks, I can say 1, 2, how many got 1, how many got 2, how many got 3, how many got 4, how many got 5. But let us say the test is for 1000 marks like UPSC. Then it is practically for me to look at how many got 1000, how many got 999. It is impossible to control the data. That is why what the people have done, instead of measuring them in the particular value, they have come up with a class interval. What is class interval? So I'm going to segregate the people in a unit test of 100 marks. I'm going to segregate who are getting 0 to 10, who are getting 10 to 20, 30, 20 to 30. So I'm making into the classes. That is where the class interval comes into picture. For example, here if you look at, instead of saying X as 1, 2, 3, 10. So what is that? 0, below 10, below 20. So 10 to 20, below 30, below 30, and 30 to 40, below 40, and below 50, 40. Now look at it very carefully. He has not given the frequency, he has given the cumulative frequency, because instead of saying between 0 to 10 or below 10, it is 5. Below 20 it is, below 20 is 16. So in fact frequency here, because out of 16, 5 are already considered. So 16 minus 5, how many of them are going to be? 11. So there are 11 people who got between 10 to 20. Now below 30, how many of them are there? 28. What is 28 minus 16? 12. So there are 12, because already 16 is considered as part of below 20. So there are 12 people who are scored between 20 to 30. Now, how many of them scored between 30 to 40? So the below 40 there are 42, which means below 30 there are 28, which means how many of them are scored? 14. Now similarly below 50, which means 72 are there, which means below 40, 32 or 42 are there. So definitely how many of them are scored? That's how this is so sometimes they'll specify the frequency, sometimes they'll specify the cumulative frequency, depends on how other is throwing the data here. So of late the levels have gone up from the frequency distribution to, they have also increased up to class intervals. Now look at what is the class mark of the model class. Now which class is having the mode, highest mode? So if you look at definitely, because 30 is the maximum number, so the highest number, which interval is having the model class? Definitely 40 to 50. Now y is the upper limit. So y is the upper limit. Y is how much? Y is going to be definitely 50. Upper limit is 50. Upper limit of the median class, sorry, y is the upper limit of the, x is the class mark of the model class, sorry, I'll come back to it. X is the class mark of the model class and y is the upper limit of the median class. Now first I need to figure out the median. Median means 72, which means how many observations are there? 72 by 2. There are two middle observations which are going to be 36 and 37. Now look at very carefully, what is going to be the 36 and 37 in this case. So 36 up to 28, between 28 to 42. So 36 and 37 are going to be the part of this class. So this is what is median. Median is going to be in the interval of 30 to 40, whereas mode is going to be the part of 40 to 50. Yes, this is the class interval. This is the class interval for median. Now y is the upper limit of the median class. So what is going to be the y value? So if you look at the median class, so y is going to be upper limit. So lower limit is going to be 30, upper limit is going to be how much? 40. Now because we are really interested in the value of 2x plus y, 2x plus y. Now what is the value of x? X is the class mark of model 1. Now if you look at, so 40 and 50, whenever class interval, so class mark will be always the average of, if you ask me honestly, I do not know. There are a lot of people who might get 40. There are, no, all 30 might have got 40, all 30 might have got 50 as well. Still they will be as a part of this class. So for a calculation, that is what statistics, for a calculation efforts, what we are going to do, we are going to take average of it. So 40 plus 50 by 2, which is going to be the class mark of the model class. So obviously it is going to be 40 plus 50 by 2, which is exactly going to be how much? 45. Now we are really interested in the value of 2x plus y. So 2 into 45 plus 40. Yes, so there are quite a few of students have given the right value, which is going to be definitely 130 as far as this question is concerned. So you also need to get a little more hold on what you call, a little more hold on what you call the class interval. Yes, but they do in TCS NQT especially, I have seen this kind of questions. They have started asking interval, but prior to last year I've only seen up to frequency distribution. Of late I'm also seeing the class interval. So let's see that you are not limiting to the, in the class I'm focusing on unorganized data, and then we have also seen the organized data in terms of frequency distribution. After this session I want you to probe little more on your own how to calculate the mean, median and mode for the class interval. Yes, but I'm not going to get into detail because that's going to be boring for quite a few students. So I'm going to focus on how to do it in a much better fashion as far as frequency distribution is concerned, how to solve little more questions, and I'm also going to focus a little more on deviations, which is also important. Yes, let's move on to the next one. This was the question. Again, this is a what? Model class. Anuja, it's very simple. The class which is representing the mode is known as model class. As simple as that. Nothing great. So, this is another question given in the last year, again TCS NQT. And now let me challenge how many of you can do it. You have absolutely 2 minutes, but very simple if you understand the logic. Otherwise, it's going to be difficult. Yeah. So let me see, you are not really interested in calculating mean, or you are not really interested in calculating mode, you are only interested in calculating median. You are interested in calculating in median. Let's see what is going to be the right choice. I'm looking forward to all of your choices. Now, floor is open to you. In fact, let me broadcast so that you can, I think, yes, I'm not added as a part of ICQ, so please see through that you are doing it on your own. Yeah, open to you. I'm giving you absolutely 1 minute, so I'm not going to disturb you anyone. Let's see how much we can do it. Dhananjay says 28. Good fight. Let me see how many. Bhuvana says 28. You need to be very careful. I keep saying you have to be really careful. Srivalli, Anirbita, everyone is saying 28. I'm hoping that all of you are not falling into the traps of TCS. And often what will happen in most of the competitive exams, they seems very easy, but then we tend to commit a lot of silly mistakes. That comes with a little, what you call, either you have seen that kind of question little once earlier, or probably you are very particular in observing the data. All of you are saying 28. But somehow I think you need to be a little careful. Let's see how many. I think that might not be a valid option. I'm giving you one more chance. Let's see how many of you can fight for it. All of you are saying absolutely 28. Okay, let me start. In fact, you should not forget the fact, whenever you are calculating the median, you need to see that you are arranging the data in the ascending order. So I have how many 20s? 6. Next bigger data 25. So intentionally as given here. So you need to be very careful. So 25 here, then 20. What is the next bigger number? 28. So 28, 24. I'm hoping that all of you are right. I'm not really sure. So I'm hoping that if you have considered this, you might be right as well. 29, 28. So next bigger number, 33, 15, 33, then you have 38, 4, 42, 2, 43, 1. Now let's quickly look at cumulative frequency, 6, 26, 50, 78, and 93. Yes, obviously 100 students, so I have to get 100. So what is going to be my middle observations? So if you look at middle observation is going to be 100 by 2. There are two middle in fact, because there are 50 and 51. Look at the beauty. 99% of them have given 28. So if you observe very carefully, 50th observation is going to be the part of 28, but 51st observation is going to be part of 29. So definitely I know it is going to be 28 plus 29 by 2. Believe me, 80% of the students have given 28, but the right choice is going to be 28.5. So don't ever forget the fact that whenever they are giving the data, you need to be a little more careful, because yes, and you need to see that you are not committing such kind of fundamental mistakes, which is in the moment you are able to solve such kind of questions, you will have little because 80% of the lot is definitely going to do such kind of mistakes. They can be avoided. Yes. So in fact, I keep saying, don't worry about the unknown areas. So whatever you are good, you need to be really good. When you say you are good, you should be really good in those areas. Yes, you need to be a little more careful. So I definitely go with 28.5 rather than 28. Yes, let's look at a couple of more things. Yeah, I'm going to just focus on deviation. Sometimes I've also seen the questions on deviation, so we should not be surprised on deviations. In fact, there are three kinds of deviations. If you are really mechanical engineer, you will get to know a little more in detail. So mean deviation and standard deviation and quartile deviation, these three are very popular, and let's focus on mean deviation. Let me take with the smaller numbers. So let's simple numbers. So let me take with, I will come back to this. Let me take 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, there are 5 students who got the observations as 1, 2, 3, 4, 5. Now, what is the mean of it? The mean we already know, because the series is an arithmetic progression. I don't need to really calculate. The mean is going to be definitely how much? Mean is going to be sum of the observation, or I can say, because the series is an arithmetic progression, people who have attended my first session, definitely I can say without doing much hesitation my mean. Now, when I say deviation, how far the observation is away from the mean, how far the observation, I'm not really whether concerned whether it is on the positive side or it is how far it is away from the mean on positive side or negative side. For example, I'll give a classic example. You are required to manufacture a shaft of 25 mm, but you are making 24.99, 24.9, or whether you are making 25.1, which is also going to be deviation. One is on the positive side, one is on the negative side. But as far as the industry is concerned, whether it is on positive or negative, for me it is a deviation. But one of the cases it is on the positive side, and another cases is going to be. But then in the industry they will also give the tolerance, because it's practically impossible to manufacture 25. So what they do give is 25 plus or minus 1, which means within the limit 24.9 to 25.1 the shafts are allowed. So once you get into the industry, you will understand how they are going to monitor. But at this moment of time, I'm not going to dwell in deep, but let's try to understand. So how far away from the observation is how far away from the mean. So if you look at 1 and 3, because the mean is 3 units, 1 and 3 are how far? Minus 2. Or because it's a mod, let's keep it as a 2, and 2 is how far away from 3? 1 unit. 3 and 3 are 0 units. 4 is 1 unit. 4 and 3, 5 and 3, 2. Now, these are deviations. What is deviation? How far the observation is away from the mean is nothing but a deviation. Now, when I say mean deviation, the name itself suggests mean of absolute deviation. When I say mean, by default arithmetic. So what is the sum of all these values? 2 plus 1 plus 3, 1, 2, 3, 3 plus 1, 4, 4 plus 2, 6. So mean, arithmetic mean of it. So definitely how much it's going to be? 1.2. This is the mean deviation. This is mean deviation. Now, what is standard deviation? What is standard deviation? So let's calculate. So mean deviation is nothing but mean of absolute deviations. The name itself indicates mean of absolute deviations. Now I'm going to discuss on standard deviation. Just focus. Let's calculate the squares of absolute deviation. So 2 square 4, 1 square 1, 0 square 0, 1 square 1, 2 square 4. The summation is going to be how much? 10. Now 10 divided by 5 is going to be how much? 2. In fact, this is popularly known as variance. Variance is nothing but variance. It is represented with sigma square. It is represented with sigma square. Variance is nothing but mean of, variance is nothing but mean means arithmetic mean by default, mean of squares of absolute deviations. Squares of absolute deviations. Absolute deviations. Yes, a little bit theoretical in nature, statistics. Please pay attention for next 10 to 15 minutes, then we are done. Now, when I say standard deviation, in fact, standard deviation is represented with sigma. I'm going to tell the significance of it little later. Standard deviation is nothing but sigma. So, in fact, standard deviation is nothing but square root of variance, square root of variance, square root of variance. So if you look at standard deviation of the given absolute series is going to be how much? 2. Yes, I hope all of you are clear. Yeah, feel free to ask me in case can you explain 21012 column. It's very simple. What is the mean you are getting? 3 units. 3 units are how far away from 1? 3 units how far? Fortunately here 3 and 1 are minus 2, but because I'm looking at absolute values, so it is going to be 2. So I'm just writing as 2. 2 and 3 are how far away? 1 unit. 3 and 3 are how far away? 0 units. 4 and 3 are how far away? 1. How do I got 3? Probably you have not attended my previous session on statistics. It's very simple. Calculate the mean. So probably for you, just add all the observation, which is going to be 15. How many observation? So sum of the observation divided by number of observation. But I've also taught in the last session, if the series is in the arithmetic progression, I can take the middle value as the mean of the series. So because there is only one middle value, directly I should be able to say 3. That's how we got it. Yeah, so I hope that Sairam, I hope I'm able to solve your query. Let's move on to a little more in detail. Let me again quickly look at, for example, look at this series. Let me take again 4, 6, 7, 8. Basically, I have taken this 4, 6, 7, 8, 10. There are 12, again 12, 13. Yes, 12, 12, 13. Hope we have taken all the 8 values. Yes. Now, what is going to be the mean of it? One of the ways I see, if I were you, some of the observations divided by, or we have also, if you look at 10, 17, 25, 35, 47 plus 12, 59 plus 13, how much? 72. How many values are there? Sorry, 72. There are 8 values. So what is going to be my mean? 9. So this is observation mu minus x. It is nothing but deviation. So 4 and 9, how far away? 5 units. 6 and 9, 3 units. I am not really concerned whether it is on positive or negative. 7 and 9, 2. 8 and 9, 1. 10 and 9, 1. 12 and 9, 3. And 12 and 9, 3. Again, 13 and 9, 4. So if you look at mean of the deviation, so 5 plus 3, 8, 10, 11, 12, 15, 18, 22. So this 22 mean, if you look at mean deviation is nothing but 22 divided by how many values? 8 values. Yes, whatever it may be the value. Similarly, if at all I'm interested in calculating the standard deviation, 5 square 25, 3 square 9, 2 square 1, 1, 3 square 9, 3 square 9, 4 square 16. So if you look at 34, 38, 39, 40, 49, 58, 58 plus 16, which is going to be 74. This 74 has to be distributed over 8, approximately I can say 9.25, and this is going to be variance. This is going to be variance, which is represented with sigma square. Our standard deviation is going to be definitely root over 9.25, which is approximately I can say 3 point something. It's less than 3.1 in fact, greater than 3. So definitely somewhere around 3, slightly greater than 3. Yes, so that's how we are going to calculate. Similarly, sometimes you'll also have the frequency distribution. Now you should not frighten with the frequency distribution. Now let's say this is the observation, this is the frequency. Now we know how to calculate the median. So how to calculate the mean? Let's calculate the mean. So 1 into 10, 20 into 2, 40, and 3, 13, 3 into 40, 120. In fact, we have already done as something similar. So if you look at the sum of the observations is how much? 300. And what is the number of observations? So total observations is going to be how much? 100. So what is going to be the mean for it? Sigma fx by sigma f, which is we in fact you recollect this is already been discussed as a part of no initial part of the session, so which is going to be mean. Now I'm really interested in calculating the mean deviations and standard deviations. Now when you look at 3 and 1, how far away from each other? 2. 3 and 1. So I'm calculating mu minus x, 3 and 2, 1 unit, 3 and 3, 0, 3 and 4, 1, 3 and 5, 2 units. But how many such observations I have? I have 10 such observations. So 0 into anything, 20 into 1, 20, 10 into 2, 20. So how much I'm getting? 80. So what is going to be the mean deviation? Sum of all the deviations or mean of the absolute deviations, this 80 has to be distributed over how many observations? 100. So what is going to be my mean deviation? 0.8. Sometimes I might be interested in the, what is that we call standard deviation. So let's figure out squares of the absolute deviation. 2 square 4, 1 square 1, 0 square 0, again 1 square 1, 2 square how much? 4. Now because I have frequency, always remember the fact whenever frequency is there, because I don't have just the observation, I have so many observations of such kind. So I need to multiply with 10 into 4, 40, 20 into 1, 20 into 1, 20, 40 into 0, 0, 20 into 1, 20, 10 into 4, yes, 40. So if you look at the sum of all of them, it's going to be 120. Now if you look at the variance, variance is nothing but sum of the squares of the absolute deviations or mean of the squares of the absolute deviation. So here 120 has to be distributed. Don't forget the fact I need to divide with 100, which is going to be 1.2. So variance is going to be how much? 1.2. What is going to be standard deviation? Standard deviation is going to be how much? Root over 1.2. It is also close to 1.1, 1.1. Now more importantly, especially on the mean deviations and the standard deviations, yes, I don't want you to dwell detail into the how to calculate for the class intervals and all. Frequency distribution itself is more than enough for any of you on when it comes to the standard deviations, but mean, median and mode I want you to look at how to calculate for the class interval. I want you to probe on your own, and similarly as far as the mean deviation and standard deviation, I just want you to focus for next 10 minutes. I'm going to give you a small gist of it, and which might be useful for a lot of other exams which you are competing for it. Yeah, I also want you to give a little more practical application towards it, because knowing them is absolutely essential. In this case, mean deviation, median, yes, median I have not calculated. Median can never be 0.8. Why? Common sense. Median can, because look at the observation. How many observations are there? 100 observations are there. What is going to be my middle observation? So if you look at as far as this question is concerned, now what is going to be sigma f? Sigma f, if at all I'm looking at cumulative frequency, 10, 10 plus 20, 30, 30 plus 40, 70, 70 plus 20, 90, 90 plus 10, how much? 100. Now what is going to be my middle observations? 100 by 2, which is going to be 50 and 51. So what are my middle observations? Both of them are definitely in the range of 30 to 70. So both of them are going to be 3 and 3. So definitely the average of it, which is going to be 3. So what is going to be the median? Definitely 3. In fact, the mode is also 3 as far as this question is concerned. Yes, everything is going to be 3. Now, just look at very carefully. Let me erase all this for a better understanding. Yeah. Sorry. Okay. Let me take this screen. Yeah, mean deviation. Mean deviation is absolutely Yes, mean deviation is absolutely pointed. Now look at all of you. Pay attention for next 5 minutes. Now let's say I've taken the data. If you recollect x as 1, 2, 3, 4, 5. What are going to be my mean is 3. If at all I'm calculating the deviations, they are going to be 2, 1, 0, 1, 2, and in fact we have also calculated the mean deviation as sum of the observations, so 6 by 5, which is going to be 1.2. If at all we are calculating the squares of the absolute deviation, squares of the 4, 1, 0, 1, 4. So if you summation of them, how much? 10 by 5. Variance is how much? I'm just repeating the reason, there is a reason towards it. So standard deviation is root 2. Now look at very carefully. Instead of taking 1, 2, 3, 4, 5, I'm taking 101, 102, 103, 104, 105. What is it? What is that I'm doing? I'm adding a particular constant of 100 to each and every element in the data set. I've added 1 to 100, 2 to 100, 3 to 100, 4 to 100, 5 to 100. Now what are going to be my mean? Mean is going to be 103 now, because my middle observation, still they are in arithmetic progression. My middle observation is going to be definitely 103. What is going to be my mean deviation? So let's calculate it here. Again, they are going to be, because 2, 1, 0, 1, 2. So again, if you look at mean deviation is still going to be how much? Mean deviation is going to be 6 by 5, 1.2. Similarly, if I'm calculating the squares of the absolute deviation, which is also going to be 4, 1, 0, 1, 4, which means what is the summation? Variance is going to be 10 by 5, which is 2, and standard deviation is going to be root 2. Now, one of the key observation, the mean deviation and standard deviations remain same. Even if I'm adding a particular constant 100, for that matter, even if I'm going to add 1000 or 1000, 1 lakh, because the mean deviation and standard deviation are measuring the spread across the data. How far the data is spreading across the from the mean, how far they are spreading across. So they are going to measure the dispersion of the data. For example, I'm sure if you visit any of the good industrial setup, you will often find Six Sigma manufacturing process or zero defect manufacturing process, or you will also find zero ppm process. When I say zero ppm, not even a single part out of 1 million parts are getting defected. So 1 out of even 1 million parts are, not even a single part is getting out of control. For example, when I mean to say, so in the industries, what will happen? Yes, let's say you are required to manufacture a shaft of 4 mm with a standard deviation of or within a deviation of plus or minus 0.2. Let's say plus 0.2 minus 0.2, which means you are allowed to manufacture 3.8 to 4.2 because it's practical. Now what will happen when you are manufacturing a shaft like this? This might happen. Then immediately operator might take control, and then there's a start and because it is practically impossible. So these ups and downs might be a coolant problem, it might be a heating problem. So they continuously monitor. They'll make sure that in fact we'll also give slight margin, because we will not give such a high margin to operator. We'll make sure that we are giving only plus or minus 0.1 sometimes. So if the machine is CNC, yes, so obviously I'll reduce, so that even if it is deviating, it is acceptable, but still I'll see that there. So this is how absolute spread of the data is measured using the standard deviation. And now the important learning, as for the, whenever you are adding a particular constant, the mean deviation and standard deviation will not get impacted, because the dispersion is not going to get changed. On the other hand, let's say I'm multiplying with a particular constant. So let me multiply with the 2, every element. So I'm taking 1 into 2, 2 into 2, 3 into 2, 4 into 2, 5 into 2. And now if you look at what is the new mean, is going to be 6, because the mid, again still the series is an arithmetic progression, because the difference between any two consecutive terms is constant. So my middle observation is going to be mean. So if you look at what is going to be my mean deviation, if you look at, 6 and 2 are apart from each other, 4 units, 4 and 6, 2 units, 6 and 6, 0 units, 8 and 6, 2 units, and 10 and 6 are 4 units. So if you look at 6 plus 6, 12, 12 divided by 5, 2.4. In fact, observe very carefully, your mean deviation is also gets multiplied by the same constant, because the dispersion is getting also spread twice compared to the previous value. So earlier if it is 1.2, now it becomes how much? 2.2. Let's look at standard deviation. What is the impact? So squares of the absolute deviation, 4 will become 16, 2 will become 4, 0, again 4, 16. So if 40 divided by 5, which is going to be 8, so the variance is 8, and standard deviation is going to be root 8, which is going to be 2 root 2. So if you look at earlier root 2, now it is also going to gets multiplied by 2. So what is the important learning as far as the this data is concerned? Sorry. Yeah, when adding a particular constant to every element in the data set, the mean deviation and standard deviation are not going to get impacted, because the dispersion is not changing among the values. On the other hand, whenever you are multiplying every element of the constant with every element of the data set with a particular constant, the standard deviation and mean deviation also gets multiplied by the same effect, because the dispersion is going to get changed with respect to the given data. Yes, now let's look at quickly onto this question, and probably then we will stop with that, because I don't want to get in a little more detail. And yeah, one more question, we will stop with that. Yes, look at the question. So set y is formed by multiplying 100 to each element of the x. Set y is formed to multiplying by 100 to every element of the x. So what is standard deviation? M is the standard deviation of, so x is having, let's say, a, b, c, d, and y is going to be definitely how much? 100a, 100b, 100c. Now 100d. So what is going to be, which of the following statements are true? So please stay focused for next 2-3 minutes, because we are reaching the yeah, I'm looking forward to your options. Lahari says absolutely they are equal. Look at very carefully. Are we adding the constant? Are we multiplying the constant? Set y is multiplied, not added. Let's say I'm giving a set z is formed by adding, then it's going to be a plus 100, b plus 100, c plus 100. Whenever, if I ask me honestly, the standard deviation here and here are absolutely same. Sigma x and sigma z are absolutely equal, but as far as y is concerned, sigma y is going to be definitely 100 times of the sigma x, because m is let's say m is the standard sigma x, y is going to be sigma y, so n is going to be definitely greater than m, I hope all of you are, yes, n is definitely going to be greater than, yes, all of you are absolutely right. So the relationship can be truly determined, no need to. So this is what I'm saying. All you need to understand, whenever you are adding the particular constant, the elements of the data set, the dispersion is not going to get affected. Now one more question, because I see a lot of mistake, something similar. Let me see how many of you can do it. Yeah, feel free to ask me in case if you have any doubts. So you have x, which is x is given as, sorry, x is given as a plus 3, a plus 7, a plus 12, a plus 18, a plus 18. Now you also have y is the elements here, b plus 2, b plus 5, b plus 9, b plus 14, b plus 20. Now look at very carefully. What is the difference? 3. What is the difference? 4. What is the difference? Spread. 5. What is the difference here? 6. Similarly, the difference being 3, 4, 5, 6. So, in fact, whatever may be the constant I'm adding here. Let's say a plus x will become b plus 2, whatever it may be value. So from there, the difference being constant, which means the dispersion among the values are absolutely same. So I definitely can say standard deviation, because whenever you are adding a particular constant, yes, it seems that most of you, I'm sure, you will say this is A and this is talking in terms of B. I cannot relate, but no, because whatever may be the constant, the dispersion among the values are absolutely same. So definitely the standard deviations are going to be same, because the moment, as long as I'm adding a particular constant, the standard deviations are not going to get impacted. So yes, this is the crux of the day. Today we have looked at how to calculate the mean, median and mode, especially for the raw data, as well as focusing on frequency distribution. And I also requested you to focus on how to calculate for a class interval data, and similarly we've also seen how to calculate the mean deviation and standard deviation for raw data as well as frequency data, and how the mean deviation and standard deviations are getting impacted whenever we are adding the particular constants as well as multiplying with a particular constant to every element of the data set. Yes, please go through all the videos once again. In case if you have any doubts, feel free to ask me. Probably in the next session I'm going to catch up with a new topic, and there are a little more in-depth detail, but I don't want to get it for various companies levels. This is more than a few, so if at all they are going definitely beyond this, I'm not seeing the question, so let's not worry too much on the bell curve. That once you join in the companies, you will be experiencing what is bell curve, how the normal distribution curve is going to get your life impacted in your life, because it's very common once you join in the industry how they are going to monitor your performance. So let's not get into in detail. Thank you all for joining, but make sure that you are not restricted into your classroom practice, and please see through that you are practicing after the session, then you will be able to maximize. Have a nice weekend. Let's catch up again. I think you have a session, so I'm not really clue. I don't know whether you have a session on tomorrow, so check your schedules and please see through that you are attending without fail. Have a nice day. Last question. Yes, very simple. Anuja, you are asking. Yes, let me. In this case, all I'm saying, what is the dispersion here? The difference here, 3. Or probably, let me say, what is going to be this b plus 2? Yes. So the dispersion a and a plus 3, 3, a plus the difference being here 4, the difference being here 5, the difference being here 6. Similarly, if you look at the difference being 3, 5 and 9, 4, 9 and 14, 5 and 14. So what I'm saying, let's assume that the b plus 2 minus a plus x or a plus unknown value, or let me take avoid the confusion, a plus m is equal to b plus 2. Can we say b is equal to a plus m minus 2, a plus m minus 2? So let me substitute here, a plus m minus 2 plus 2, which is going to be how much? These two get nullified, so 2 get nullifies, this is going to be a plus m. Agree? Now similarly again b plus 5, which means can we say a plus m minus 2 plus 5, which is going to, can we say this is going to be a plus m plus 3. So similarly, if you look at a plus m minus 2 plus 9, which is going to be a plus m plus 7. So if you look at, I'm writing this values on here for a better understanding. This is a plus m, this is a plus m plus 3, this is a plus m plus 7, and similarly if you calculate here a plus m minus 2 plus 14, which is going to be a plus m plus 17, 12, sorry, a plus m plus 12. Similarly you will end up getting a plus m plus 18 here. So if you look at here, the series is a plus 3, a plus 7, a plus 12, a plus 18, whereas the other series is going to be a plus m, a plus 3 plus m, so a plus. So what is the constant is getting added? There is a particular constant m is getting added, so the dispersion is not going to get impacted. So I don't need to really do all this. all I need to is because the dispersion among the values are going to be same, definitely the standard deviation is going to be same. So the right choice in this case is going to be 3. Yes, thank you all. I hope you all of you enjoyed the session, and we'll catch up again on the next session. Thank you. Have a nice day.